Hello mathematicians, and welcome to 3B.1 Solving Inequalities. Our essential question today is, how do I solve an inequality? Go ahead and grab those needed supplies, your writing utensil, math notebook, a growth mindset, and some determination, because we have two different learning goals today. We want to be able to, by the end of this video, say I can solve a one-step inequality and I can solve two-step inequalities. Let's go ahead and dive in with some vocabulary. We have a Ferrer model here so that we can get a lot of information about an inequality. If we're going to solve them, we have to know what they are. So let's just take a peek at that word inequality. What do you see there? You see equal, okay? But it has a prefix of in. What does that prefix in means? Yeah, it means not equal, right? So the definition of inequality is it occurs when things are not equal, okay? So some characteristics. It uses these symbols, less than, greater than, less than or equal to, greater than or equal to, and an inequality has more than one possible solution, which is why it's not equal, because there can be a lot of things that work. Some examples: x is greater than 4, or even x is less than or equal to 2. Non-examples: anything that's equal, because again, inequality, not equal. So we just talked about these signs, but let's go ahead and write those down and make sure that we know which is which. You have the less than sign, starts with an L, points to the left, also starts with an L. Greater than, less than or equal to, because it has this underline, that's like part of the equal sign, and then greater than or equal to. So the good news here is that you're really not going to be learning a lot of new information, because when we solve inequalities, we do it the same way we solve equations, and we already know how to do that. However, there is an exception. There's one little hint. When you multiply or divide by a negative number. But we already know what that does, whether it preserves or reverses our sign, thanks to some work that we did previously. But we know that when you multiply or divide it by a negative number, you have to flip that sign. You have to reverse it. Okay, so let's start with a one-step inequality. Remember, we solve these just like an equation. So I have 4x is greater than 12. 4 times something is bigger than 12. So I'm going to do the inverse here. I've got 4 times something. The inverse of multiplication is division. So I'm going to divide by 4. And then I'm going to do the same thing to the other side, just like when I solve an equation. So 4 divided by 4 leaves me with x. I bring down that greater than sign. And 12 divided by 4 is 3. So x is greater than 3. All right, some possible solutions. That just simply means x can be literally any number bigger than 3. 1 million. That works. 542, that works. 4, that works. Any number such as 4, 8, or 10 that is bigger than 3 can be x. So what that kind of looks like here, let's say the solution is 4. 4 times 4 is 16. 16 is greater than 12. Let's do the 10. 4 times 10 is 40. 40 is greater than 12. So some things that are not possible solutions, anything that is 3 or less. So 3, because 4 times 3 is 12. 12 isn't greater than 12. 12 is equal to 12. 0, 4 times 0 is 0. 0 is not greater than 12. So anything that is not bigger than 3 is not a solution. Okay? Let's look at another one. Negative 5x greater than 30. I'm going to do kind of that same idea. So on this side, I'm going to divide by negative 5, because I'm going to do the inverse. I'm going to do the same to the other side. Negative 5 divided by negative 5 is 1. 30 divided by negative 5 is negative 6. X is less than negative 6. Notice that sign flipped because I multiplied or divided by a negative number. So possible solutions, if x is less than negative 6, possible solutions are any number less than negative 6. So negative 6.5, negative 8, negative 10. Things that are not possible solutions are anything bigger than negative 6. So negative 4, 0, 2, 9. Those would not make a true statement if I plugged those back in. Let's try it with a two-step. Okay, bringing back those memories of two-step equations. I'm going to get rid of this plus 5 first by doing the inverse, which is minus 5, and that gives me 0. And then I have to do the same thing to the other side. So 17 minus 5 is 12. Now I'm left with 2x is less than or equal to 12. The opposite of this multiplication here is division, so divide both sides by 2. And I'm left with x is less than or greater to 6. So some possible solutions: anything that is less than or equal to 6. So in this case, it can be 6. Not possible solutions: everything else. Anything that is not less than or equal to 6. All right, one more two-step. We're going to get rid of minus 4 first. The inverse of minus 4, or the opposite of that, is to add 4 to give us 0. And then go to the other side and do the same. 2 plus 4 is 6. Now I have negative 3x is less than or equal to 6. I'm going to do the inverse of what I have here, multiplication. So the inverse is division, dividing by negative 3. Going to the other side and dividing by negative 3. X is greater than or equal to 2. Again, notice that sign change because I divided by a negative number. And then we have here our possible solutions and things that are not a possible solution. All right, you are ready to pause this video and try a few on your own and then come back and check your work. Okay, hopefully this is what you came up with for those 4 problems. If not, go back and rework them, ask questions, figure out where you went wrong. That, mathematicians, is the end of 3B.1, solving inequalities, where you can now answer the essential question: how do I solve an inequality? Thank you, Amy Grossbeck, Amanda Newsom, and Write Lovely for your amazing fonts and clip arts. Mathematicians, go forth and be amazing.